our geometry review. Review number 8, and this one we're focusing on angles. There's a couple of sets of angles problems in the review. These are useful, I think. Let's look at angle problems number 1, which is problems 81 through 82, 81 and 82. Okay, so in this picture we have a triangle given a fairly large picture of a triangle, and we're told that inside we have an equilateral triangle, ABC. So we are told that ABC is equilateral. Let me mark that, 3 equal sides, and we know we have 3 equal angles. All equilateral triangles are also equiangular. Okay. We also know AB is parallel to DE. AB is parallel to DE. I guess we should label DE down here. DE. And up at the top we have F. Okay, and lastly we're told that angles D are 65 degrees down here, and angle F is 50 degrees up the top. Okay, and the task is to find the measures of the other angles and write them on the figure. Okay, so let's see how we might go about this. We do know that when you have parallel lines cut by a transversal, we know that this and this are parallel. Here's our transversal. Okay, we know that corresponding angles have to be the same. Remember what a corresponding angle is. If we move, well, let's see if we can do this. Let me make this in green. Here's our corresponding angle. I'm going to slide that along the transversal and put it right there. I guess I should get this guy back down a little bit. There. Okay. So our corresponding angle, 65 degrees. If we slide it along the transversal, this is also going to be 65 degrees. Okay, parallel lines cut by a transversal form equal corresponding angles. Okay, lastly, we know that angles of a triangle have to add up to 180, so that will give us this one over here. Let's see, we've got 65 at this point, right? Because 65 and 50 is 115, and subtract that from 180, and we get 65. So that's how I got this one, and this one. I added up, subtracted those two from 180. Okay, let's see, another angle. How about over here on the left side? We know that these are all collinear, so this triple right here, and it's not the same as a linear triple, but a linear pair adds up to 180. These 3 angles have to add up to 180 as well. So this has got to be 55 degrees, right? 55 plus 60 plus 65 is 180. And so that will give us the one down here, also in the same triangle. We have 55 and 65, so this has got to be 60. These 3 in this small black triangle have to add up to 180. Okay, we're getting there. Obviously, the 3 angles on the bottom are all 60, again, for the same reason. All 3 of these have to add up to 180. And over on the far side, this, by the way, this figure is symmetric. It's got line symmetry right down the middle. It's pretty obvious from looking at it, and as we start to look at the left and right side, we see it is true. But if we just sort of noted that, we could see pretty quickly that this angle over here at B has also got to be 55 degrees, and this angle in the corner has got to be 65 degrees. Okay, so that gets us all our angles. Okay, what else are we supposed to do? What can you conclude about triangle ACD and BCE? Okay, ACD is this one over here. I'll do this one in green. And BCE, let's do that one in red. BCE, what can we conclude about them? Well, let's see what we know. We know they both have a single tick mark here, so they have a side that's the same. They have a 55-degree angle, both of them. So they have an angle the same, and they have a 60-degree angle. down here, and down here. So two angles and the included side of one, two angles and the included side of the other. So sure enough, we can say triangle ACD is congruent to triangle BCE, and the reason would be angle, side, angle, postulate. Okay, and that would be angle problem 1. Let me pull up a new screen and let's flip over and look at angles problem 2. These are 93 and 94. So 93 and 94. Again, it looks like we have some parallel lines going on. So this is L1, L2, and we have a transversal here going from A to B, and we have a angle or a line that comes over like this. We're told that this angle is 100 degrees, and we're also told that AC, here's AC, that will bisect, or AC, this segment right here, bisects angle BAD. Okay, so this blue angle is cut in half, cut into two equal parts by this red segment here. So these two have got to be exactly the same. Remember, bisect means cut into two equal parts. Okay, and our task is find the measures of the other angles, write them on the figure, and then what can you conclude about triangle ABC? So what type of triangle is ABC? Well, let's do the parallels first. Again, we know that this is parallel to this. That was given. And so we have these two parallels, and we have a transversal right here. Okay, and we know that two parallel lines cut by a transversal, angles on the same side, these interior angles here, have got to add up to 180 degrees. So these two have got to be supplementary. So that gives us 80 there. Okay, likewise, this is our transversal, and the alternate interiors, this 80 up at the top, is going to be the same as this 80 at the bottom. Those are alternate interior angles. We could have reasoned that a different way, obviously. This is a linear pair right here, so they have got to be supplementary, 100 and 80. Okay, what else do we know? Well, I guess we got to go back up to the top here. If we look at this linear pair, we've got 80 and we've got this large one. Right, those two have got to be supplementary. So this big blue one has got to be 100. Right, 100 plus 80 is 180. But the two asterisks, the two red ones, say that they're cut in half. So each of these have got to be 50 each. Okay, so 50 here and 50 here. Okay, so that doesn't look too terribly bad. Now, what can we say about this triangle? Well, I guess we should find this poor little lonely angle over here by itself. We do know the angles of a triangle have got to add up to 180. We've already got 80 degrees here. We've got 50 degrees here. So this has got to be 50 degrees over here. And lo and behold, we have two angles that are the same. So remember the converse of the ITT, isosceles triangle theorem, says if two angles of a triangle are the same, then the sides opposite them go all the way across. This side has got to be the same as this side down here. Okay, so two angles the same, the sides opposite are the same. This blue triangle will be an isosceles triangle. Okay, so let's go ahead and stop this one here.